Hello, and welcome to my IoT project presentation. I chose to use this platform to build an IoT system that keeps track of the groceries, supplies, and usages, and automatically produce a shopping list. Before diving into the code overview, I want to show you the overall flow of my system. As part of my project requirements, I was needed to connect my Pi, which is represented by the right rectangle here, to cloud, Bluetooth, and an external scanner. When running the program, the user may send a receipt over Bluetooth, and then the system will process it, or use the scanner to add or remove an item. In response, both the database, which is a Google Sheet document, and the shopping list, which imported into TickTick application, are updated. And I can access this application from my cell phone to get an updated shopping list when buying groceries. So, as you probably assumed already, this system contains several components that needs to be integrated carefully. This is why I wrote several packages so that I can validate and test each one separately. In total, I wrote 5 packages. Spreadsheet service that reads and writes data frame from Pi to cloud to Google Sheet. TickTick utils that sends the groceries list to TickTick application. Bluetooth image server that enables the user to send a receipt over Bluetooth from cell phone to Pi. Scanner that handles the code scanning inputs. And text recognition that extracts product codes from receipt image. Now, I will show you each of these packages and also the main script for running the program. Hello, my name is Inbar and I'm very excited to show you the demo of my final IoT project. We will start with showing you the setup of the system. So we have a Raspberry Pi connected to a Pi touch screen, a scanner which is connected to the Pi via USB port, and this small little QR cube. The cube contains 4 user modes and 2 possible user responses. In our system, the user can choose to either add an item, remove an item, scan new receipt and ask the system to process it, or exit from the system. And when a question is pop up from the system to the user can either accept or reject. Okay, so our system holds inventory list and update automatically the shopping list based on the inventory status. This list is automatically synchronized to a TickTick application, and now I'm going to show you that after adding coffee and milk, this list would be updated since I don't need it to buy those items. So back in my system, I'm choosing to add an item and I'm scanning its code. So this is the coffee, and we also have a milk. And now you can also see that it was immediately updated in my TickTick list. And similarly, I can also remove an item. Those two modes are pretty similar in their nature. Coming back from the super, it would be much more convenient to send the whole receipt to the system, to the file, and ask my system to process it. The way that it works is that I first need to take a picture of the receipt, and then I need to send this picture via Bluetooth to the file. After I got the notification the receipt was sent, I can ask the system to process new receipt. What is going to happen now is that for each unrecognized code, the system will ask me if I want to ignore this code, add this code to the database, or rescan the item. Okay, so this is example of code that I want to ignore. So I'm just scanning the reject QR code. And this is true for those codes as well. And oops, I see that now we're having an item that is missing from the database. So I'm choosing to rescan this item and add it to the database. And this item I want to ignore. And this is it. Now the receipt is processed and the file is moved to another folder of the processed receipts. We will start with spreadsheet service package. The code is written under the script here, and this library I'm using for reading and writing from and to the Google Sheets. The main functionalities under a spreadsheet handler class is loading database from the cloud, which happens on initialization of the system. And before exiting the system, I'm updating the database back to the cloud. When I first built the database, I chose those fields here to describe each item. We have the item code, a short description of the item, flag that determines if the item is edible, partition into category, dairy, meat, for example, optional subpartition into specific category. For example, for dairy item, it can be milk or yogurt. Comment, which is also optional. Flag that determines if the data is valid. I need this flag because when item is first inserted into the database, some of those descriptions are needed to be added manually, and only afterwards this flag is set to be true. This required field, the default is 0, and it states the amount that I want to hold this item on a regular basis. This field stock is the inventory of the item, how much we have currently, and the date is for the last update in the item's inventory. Another thing to note here is that this method, update database to cloud, is also calling the send list method from TickTick utils package. This way, when I'm updating the database, I'm also updating the shopping list. And what I chose to implement is that for every item, I check the required field and the stock field. And if I need more than what I have, then I'm updating the shopping list. This script here is responsible for exporting the shopping list. I'm using this library for synchronizing the shopping list with the TickTick application. And as I already mentioned, this method is responsible for sending the updated groceries list to TickTick. Next, we have the Bluetooth image server package. Here we have some parameters settings, like the folder to which new image is sent from the cell phone, and the folder in which a processed image is moved. You can also see here the command for starting the Bluetooth communication using OBEX protocol. The server is turned on a system initialization and turned off before exiting. Each time the user chooses process receipt mode, the iterator here is loading a new receipt from this directory, and this file is automatically moved to this directory, process the image directory, afterwards. Here we have the code responsible for code scanner readings. I'm using this library to identify all the devices that are connected to the Pi. The scanner is connected to the Pi using USB, and I'm verifying this device is indeed connected on the system initialization. Here you can see the mapping I wrote from the scanner inputs to either numerical barcode values or digits of the QR codes. And this method here, scan code, is responsible to send the translated code back to the user. This part is responsible for the text recognition process. Basically, what I did here was to apply an OCR algorithm that detects all the codes from the receipt image. This is based on the Tesseract library, which is an LSTM neural network that is trained to extract letters and characters from images. And I used the PyTesseract package to run the library from within Python. The main class here is invoice reader, and the constructor calls process image, which returns list of codes. It first crops the code columns, and then it calls getLine row data, which returns each code line. I decide which line contains a valid code based on the detected sequence length. Here, there are two visualization methods. One plots all the codes in the receipt, and the other plots a single line. Finally, this method asks the user to enter description for unfamiliar codes that were found in the receipt. This is useful for annotating the database for the first time. So here it iterates over each new code, and I'm showing the user the image of the specific line, and then the user needs to add a description. After showing you all the different components of my code, the only thing that left is the main script responsible for running the program. I'll start with this script modes. And here, the three main user modes, add, remove, and receipt, are defined. All of them inherit this class mode. And I define here all the functionalities and properties that each of those user modes should have. For example, does a code exist? Adding to the database, updating the inventory, and even for my convenience, using different color when writing to the logger from each of those modes. When the user chooses to add or remove an item, the user uses only the scanner, and assuming the code exists in the database, only the inventory need to be updated. Otherwise, we also need to update the database itself. On receipt mode, this process receipts method is called, and this method reads each line in the receipt image. And if a code doesn't appear in the database, the user is asked to either ignore, accept, or rescan the code. Rescanning is for cases that the code extraction from the image was incorrect. Finally, we have this main script for running the program. This section here is an exit sequence, and here is the initialization of the system. I'm connected the system to the Bluetooth server and the scanner, and also returning the spreadsheet handler to get the updated database from the cloud. And while running, the user scans a QR code of the mode he wants to use now. It can be either add or remove an item, or processing new receipt, and alternatively, the user can choose to exit the program. By this, we are finishing with the code overview, and I'm happy to show you my system in action.